Hi, everyone.
Hello.
Hello.
That's remorse.
Looks like we have a pretty good group going so far. I think Wendy has already started recording. So we'll have this for future generations. So welcome, everyone. Hopefully Tom will be joining us. His emails were bouncing and he asked me to send him the link. So I had to call him and give it to him on his phone. Hopefully he'll be able to get here before the meeting's over. We're fortunate tonight to have somebody else presenting besides Tom and myself, and that's Doug. And Doug has offered to give us a little walkthrough of his approach to data acquisition. So since he's going to cover a lot of stuff, we thought it'd be better if you held your questions to the very end. If something's burning a hole in you, I guess you can scream out, but if you want, just try and hold off to the very end because he'll probably address what it is you had a question about. But I'm going to go ahead and turn it over to Doug and let him start sharing his screen.
Okay, let's see if I can sort that out real quick. All right, screen 2, share. And let's see if we can. Okay, so does everyone see my screen?
Looks good.
Okay, great. So I'm happy to be talking about this acquisition workflow tonight. I hope that something I'm going to say is either going to help you or tickle thoughts in your head that can help me. So with that, hopefully we'll have a two-way dialogue at the end. A little shout out to Kevin Cook for this picture. I was originally unwilling to have him take this picture, and then now I really like it. So thank you, Kevin. Okay, so what I want to do is maybe go over my gear just a little bit, and hopefully that'll illuminate some strategy considerations. I'll talk a little bit about my planning and prep, but most of the time I'll spend probably on the control software for guiding, alignment, focus, and sequencing. And then I do want to talk just a little bit about data metrics and archival at the end. So a lot of you know that I have a Rowe-Ackermann-Schmidt astrograph, commonly called a RASA. It's an 11-inch fast F2 astrograph. I'm using the CGXL, which is Celestron's heavy mount. And I'm using it in an unconventional way. RASA was supposed to be a wide field telescope, and I intentionally went out and looked for a camera that I could use in the way I wanted to use it, which is I want to see galaxies. And so I went out and selected the 183 MC Pro. The reason why I did that was because it's a one-shot color, and I'm an impatient observer. And it's got the smallest pixels I could buy, 2.4 micron pixels. So the weakness of that camera is that it has a 12-bit ADC, and that's going to be definitely something we're going to have to, is going to affect our strategy. So I'm imaging at 1.3 by 0.75 field of view, and the plate scale is 0.8 arc seconds per pixel. My guider is nothing special. I put a 2x Barlow in there so that I could keep the guide scale a little bit closer to the plate scale of the imaging system. And then another thing I did was I replaced the RASA optical window, which is a clear glass window, with a modified Hoya UV IR filter. And I'll explain that in just a moment. So this is the design of the RASA. It's an astrograph. There's no eyepiece, okay? The camera goes on prime focus. And so this is not a secondary, it's lens. And we've got to fit the camera in this envelope or we'll be blocking light going into the telescope. So the field that the RASA can handle is actually big, okay? They market a 52 millimeter max chip size for a usable field area. So what you've got here are concentric circles for the usable field, a full frame camera, APS-C is the box inside, and I drew in my little 183 down in here. And so the size of that 183 is only 4.4 millimeters and 6.6 millimeters off axis. Okay, so that's something to remember. So the thing that might first strike you is, wow, I'm giving up a whole lot of field here for this 183. And it's true, but what I'm gaining is I'm gaining resolution and I'm gaining image quality. And we'll see that in just a moment. Okay, so first to the Hoya UV IR filter. The 183 is sensitive to a lot more light than what we want to see. And so I want to get rid of all of that because I don't want that impacting the image quality. And so I put in a nice strong cut in the optical window. It's there full time, all the time. And that makes it pretty nice for image quality. Okay, so I'm not sure if you've ever seen a spot diagram before, but what we've got here, this is straight out of the RASA design documentation. This is the image quality. And what we're looking at are boxes of 9 micron size. In my image scale, that's 3 3/4 arc seconds. So what across the top is wavelength and down vertically is off-axis distance. And so for my system, what I've got the Hoya is pinning me in a nice, neat, constrained environment left and right. So I don't have to worry about what the spots look like outside of what I'm seeing here. And downward, I'm pinned by the 183 in this top section of this green box. And so remember I said it was 4.4 millimeters on the short axis and 6.6 on the long axis. So even though this whole spot diagram is considered usable and well within 4 arc seconds, I'm in the sweet spot, pun intended, for for the system. So I think my image quality is pretty nice if I can get the mount to behave. Okay, so now about that 12-bit ADC. So I'm going to start this discussion at unity gain. Everyone likes to talk about unity gain. That's the place where this curve comes down and touches 1 electron per ADU. The problem with unity gain for me is that if I go up and look at the full well, I'm only getting about 4,000 counts for full well, and that's awfully skinny. I would prefer to be twice that number. Again, so unity gain is about 120, and if I'm at unity gain of 120 on the other side, the dynamic stops that I get is less than 11. Okay, so I'd like to gain an entire stop, and I'd like to double my full well. So in order to do that, I'm going to use a gain of 50. Okay, the penalty for that is not too bad because of the CMOS. I'm only penalized by half an electron RMS, so that's not too bad. It takes 2 electrons to make an ADU where before it would have taken 1, but the RASA is collecting a lot of light, so that's not really an issue. I think I can live with a 50 gain. Okay, if you've never seen the tables for minimum exposure length on your cameras, I recommend you go out to cloudy nights and look around. There's calculators, there's tables. I found the tables for mine. And the way this reads is this is a broadband. They have narrowband as well, but I'm mostly using broadband at the moment. This is a very dark sky, CAC-like, and I'm at gain 50. And so I just go over to the right, find my F2, and 30 seconds is what they recommend. And that's actually what I'm using. A little bit unfair. I probably, since I'm using a one-shot color, I should be longer, but in general, I've been using 30 and I'm mostly getting away with it. Okay, so a funny thing happened on the way to cable management. So I started down the road of thinking about how am I going to get all these cables from the top of the telescope down to my computer. And then eventually what dawned on me is that, no, I'm thinking about it wrong. I need to go the other way. I just need to take a couple wires, maybe just one, up from the bottom of the telescope to the top and put my computer on the telescope. And so that's what I did. I put a Raspberry Pi on the top of the computer, or on the top of the OTA, and it's running the telescope control and sequence control. And I'm using K-Stars and ECOS, which you may or may not have heard of before, but kind of a nice little package. I use VNC or other remote desktop software to get to the Pi 4's desktop from the laptop, and I can communicate either wirelessly or using an Ethernet. Ethernet has quite a speed advantage over wireless, and so I did wind up running 2 cables up because of the speed. Okay, so this is the Raspberry Pi, if you've never seen one. It's a little single board computer inside a case here with a fan. I added an SSD, a 120 gig SSD, which serves as the boot drive for this little Raspberry Pi and the image storage. So don't let the size fool you. This thing can be a desktop computer replacement. So it's actually quite powerful. This is what it looks like on the OTA. So I've got a pocket box. On top of that, I've got the Pi, this little power converter, one power line going into the pocket box, and then the pocket box distributes power up on top, and one data cable coming out of the Pi 4, and it goes into a powered USB 3 hub, and then everything else is up on top. The focuser isn't shown here. You can see some of the custom cable work I did, which is mostly just cut and splice, so that the cables were nice and short. This is what it looks like in the field at CAC. And I'm pretty happy with the way all this turned out. You can see my wires. I got 2 wires coming up, and really those will be bunched together in a wrap. So the other thing to note is that the hand controller is riding on the deck axis. I don't use the hand controller at all. I have to initialize at the beginning of the night, but that's it. Once it's initialized, I'm done. Okay, a quick note about the CGX mount. I was very surprised that Celestron sends out these mounts with so much periodic error in them. When I measured over 17 arc seconds of periodic error, and I was kind of blown away by that. It's easy enough to run periodic error correction software, so I just ran a set of 10, it was 10 to 15 worm cycles, averaged them out, uploaded that to the mount, and I was able to beat that down to 0.1 arc seconds. So I don't know why they just don't do that at the factory. They probably should. But all of that was taken care of except for this one little very short blip that has a period of 21 seconds. And after a lot of pulling of hair and gnashing of teeth, talking to engineering, it turns out that Celestron, this belt, this rubber belt, and these teeth on that rubber belt, when they engage the motor, they cause this little blip. And it's not, it's not overly damaging. I might have to throw exposure out every once in a while because of it, but generally speaking, I'm okay. Okay, so my strategy kind of flows from the gear with a little exception, and that is that this is my first year imaging. And so I started out thinking I was going to go into survey mode. I wanted to just use the telescope and blast the entire sky, everything I could take a picture of, to see what the strengths and weaknesses of the system were. And that would help me learn, I'd figure out, and then I could tune in the years to come. And that's actually worked out, I think, pretty well for me so far. The next kind of big strategy factor is mitigating that 12-bit A to C weakness. And so I talked about increasing the dynamic range and the full well. I want to avoid blooming. And so I'm using, again, a little less than half unity gain, 50, and short 30-second subs, and then I'm stacking. For me, empirically, I thought I would spend a half hour to an hour data capture per target, and that gets me in the ballpark. It gets an image, may not get a great image, but it gets a decent image. And that's where I've been kind of living, making my bread and butter. The implication of that, though, is that a 10-hour dark night means I'm going to be looking at 5 to 10 targets per night. And so that definitely requires some pre-planning and some attention when you're at the telescope. So I use Stellarium, that helps me with my target selection, and especially if I have to make a change at night, it helps me, choose targets, frame them up, make adjustments if necessary, and I also need a little focus support, which I'll talk about in a moment. I use Excel spreadsheet for my pre-observing checklist, and I religiously follow that thing because I will screw it up every time if I don't follow my checklist. And then the Excel spreadsheet also helps me with my drift align star candidates, my focus calculator, and monitors my plan. So if you've never seen Stellarium before, this is a quick shot of what the Stellarium user interface might look like. Lots of capability here. If you're not happy with your planetarium software, highly recommend it. And the price is right. It's free. So as an example, this I think is about right now, 8 o'clock. And I'm looking at AGC 253, and if I wanted to, I could just roll the mouse, and I would get a DSS image for the galaxy. My camera and my telescope are already in Stellarium, easy enough to add, and even the rotation angle can be added. And so if I need to do a framing at night because the sky isn't working out in the area that I want, and I go searching for another target, I can quickly find something and make an adjustment. The elevation overlay is going to be very useful for focusing, and I'll explain that in just a moment. Okay, so this is an example of what I have in the background of my computer. And so as an example, this was last month's CAC run. So 11 hours in the night on the top. I was there for 6 nights. This gives you an idea of how many targets you're going to visit, right, in that strategy. So clearly you need something to help you remember what you're doing. And this is my plan, and this is what I actually observed. And then I make notes about if I run into trouble, if I have problems, I make a note of it. These are my drift align candidate stars. And this section is primarily because I'm fast. My critical focus zone is only 12 microns in F2, F22. And so I have characterized my focuser, and all of my focus runs, I managed to figure out what the temperature and the focus position relation is. And then the deviation from the trend line has actually a correlation to elevation. And so if I know the elevation and the temperature at the time I'm going to go, I can know approximately where my focuser position needs to be. And that makes the focusing job a lot easier for the software that's going to do it. So you'll see that in a little bit. Okay, so now I want to switch gears, and I want to go in and talk about K-Stars and ECOS for a moment, the software. That community, this is an open source community. It's free, it's shareware basically, and you can get it for free. If you're a little bit lazy like me, you might want to just purchase the bundle. It'll run on Mac OS, Windows, and Linux. The Raspberry Pi is a Linux system. And if you want to bundle it on a Raspberry Pi, you can just pay $50 and get it all bundled. Then you get an executable where you don't have to compile it and load it yourself. I've given you a couple links in case you like what you see by the end of the night. And let me tell you, YouTube is your friend here, and so is simulation. Okay, ECOS has a significant set of simulation capabilities. You don't have to learn ECOS at night. Learn it during the day with simulators. Okay, so this is the desktop of the Raspberry Pi. It comes bundled with PhD and K-Stars. And if you launch the K-Stars GUI, then you see this. You get what they've got is their planetarium software, which again, I said I'm using Stellarium. There's a lot of nice features of especially the user tools of K-Stars, but I'm not using it. What I'm using this for is I'm using it to launch the mount control, which I'll slew all night long with. That's this button here. And then ECOS is over here, and I'll launch that as well. And once those two are launched, then I just minimize this GUI and use this for the rest of the night. Okay, so when you launch ECOS, you start in this GUI. And the way ECOS is set up is this all tabbed. Everything below these tabs changes as a function of which tab you're on. So you've got the main status screen, you've got some analytics, a CCD control, a focuser, telescope, alignment, and guider, okay? And so this is where you start, and this is where you would look at your logs, you start and connect to your equipment, and generally speaking, once everything is running, you get to see the status of your image capture, your job status, and your guiding status. These two are less interesting because you're going to be, not paying attention to them as much. Okay, so I mentioned the simulators. You should start with the simulators if you're just learning this, and that's how I learned it, and it was fast. The simulators are good, but eventually you're going to need your own equipment, and so you need a profile. You can have N of them. If you have different gear, you can set up a different profile. Essentially, all you're telling the profile, you're just naming it, and you're saying whether you want to use the ECOS guider, which is their internal guider, or do you want to connect to PhD2. PhD2 is seamlessly integrated. After that, you have a bunch of pull downs where you just go find your equipment, set it, and then save it, and you're off to the races. After you're done, you can just connect, okay, back on the status page, and you have disconnect, or you can look at the logs or what have you. Okay, so now we're connected to our gear, and what I should say about using the hand controller at the beginning of the night is I do have to initialize that hand controller, but I do not run a pointing model. I don't do N-star alignment at all. I just skip that and go through a quick align, which basically skips the alignment totally. And personally, in my opinion, plate solving is the bomb, right? That's what everyone should be using now, is plate solving. And so I will slew the telescope. It's not going to land on the field, but it won't be terribly far off. It might be a degree or two. I will push this capture and solve button, and it will take a picture of the sky where the telescope actually is. It will calculate the error. It will look at the accuracy, and it will slew to the target until it gets there. And plate solving is so good now, it only takes a couple times max, and we're talking seconds now. The index files to do the lookup are on the Raspberry Pi, so it's not a internet kind of search. It's local, so everything is really fast. I will do this over and over for every target, and I never do a N-star alignment. Okay, so once I'm on the field, now I'm going to start the guider. This is a picture of the ECOS guider, and they've made a lot of strides in the last year on this guider. That you can do a single star, you can do multi-star. They have predictive periodic error algorithm in here, and they're format compatible with the PhD log viewer. So quite a bit of work has gone into the guider ECOS, and I probably would switch over right away if it weren't for the fact that I don't have Polaris at my house, and so I've just drift aligned, and I use the drift. They don't have a drift align tool in ECOS. They have other alignment tools, which I just haven't learned to use, and so I'm lazy. I stuck with the drift align. But okay, so we're on the field, we're guiding, and now it's time to touch up the focus. And like guiding, there's multiple algorithms for for guiding or for focus control. They have a patent off mask, aid. I like to use an annulus multi-star HFR algorithm with a V curve. And so I have a motorized focuser, and this is where that calculation comes into play. So knowing the temperature and the elevation of my target, I can precede this value, click this button to just set the focuser there, and then push the autofocus. And that basically sets my sweet spot. I'll be somewhere down here at the bottom of the V. When it starts to run, it backs up, makes a run through the V until it recognizes the V, and then backs up again, not quite as far, and finishes it off. This whole process takes about less than 2 minutes, and you're focused. I think for fast focal ratio scopes, it's better to know your focuser and characterize it first. For long, for long focal length, it's not going to matter quite as much, although it's still going to be helpful. It's still going to make your focus efficient. Okay, so now I want to talk about, so we're focused, we're aligned, we're on the field, how do we get a job going, right? I mean, let's actually do some work. It turns out that ECOS can run autonomously. It has the capabilities of actually running a complete startup and shutdown of your observatory unattended. Um, it can start up, it has a bunch of job constraints, and you can set up your sequences for flats and filters and what have you. But I'm only doing one shot color. And so, and I'm at the telescope, so I don't really need all of this capability, but I mention it because it's here, everyone uses it and they love it. I probably should use it, but I can use a simpler interface, which is just a CCD control. And so I can load up a file that's got all my parameters in it, which is how many exposures do I want, what duration with the gain and delay parameters that I want. Then I just add a line with this button. It puts a line here, and then I just start it, and I'm off to the races. I'll watch my status down here as it's going, or I might go back to the guider tab or to the overall status tab and watch the job as it goes. So this is a rinse and repeat kind of thing. After every sequence is done, when I'm done with a target, I'll go back to the mount control and K-stars, slew, do a plate solve on the field, turn on guiding, touch up the focus, and come back here and launch another sequence. And that's kind of the whole magic, rinse and repeat. This is what it looks like. Believe it or not, it actually does all fit what I need on a laptop. It's crowded, but with some strategic placement of windows, you can always get to where you want to go, and it works out. It works out okay. So when I'm all done for the night, I'm going to have about 10 to 15 gigabytes of data on my SSD. And so I'll start that image and log transfer before I go to bed. And in the morning when I get up, I'll just shut down the Pi 4, and that's when I start looking at metrics. So I'll take my sub-exposures and I'll run them through. I like CCD Inspector, but I've used the PI, the PixInsight subframe selector as well. Either one would be fine. I just have gotten used to using CCD Inspector for the format. And I'll cut any garbage that I see that I don't like. I'll just whack it from the report. And then I'll typically take the remaining subs and I will sanity check them by blinking them in PixInsight. And then I'll cut again. If I see something there I don't like, I get rid of them. I'll take the final subset of the merged metrics report and I will merge it into my archive. And then I'll do a sort because I might have old data and new data now together. And hopefully when I do the sort and look at the overall quality of what's left, I don't throw away all the data I just took. I'm hoping to get rid of older, weaker data. And so that is how I basically set myself up for post-processing. I do everything by the report coming out of the archive. So when I just look at my archive report and see what I want to post-process, and I use PixInsight for that. Okay, so as an example of my metrics, I've got here, my archive is nothing more than a giant Excel spreadsheet. For every object in the Excel spreadsheet, I've got a summary line that basically, puts out the averages of the report and some totals so that I can keep track of what I've got in total time. And I've got some homegrown metrics in here for each of the subs, but most of this is coming out of CCD Inspector, and PI would do the same thing, right? Aspect ratio is eccentricity, but essentially, you're looking at an overall report, and then this goes on and on and on. One thing I think it's important, I'd like to convince everyone here that it's important to measure your data. This is cumulative archive metrics. So right now, for instance, I've kept 6,000 sub-exposures this year. This is the elevation distribution for those exposures, and I can learn something from this. It's easier to learn from what you see up here in the full width half max. I can't, right now, I'm not doing any better than about 2.25. That's the best I've done. I'm living in a regime that you can see the elevation elbow here, okay? At 10 to 15 degrees, I'm not doing any better than, 3.5 to 4. I'm very interested in talking to anyone who's doing metrics on their own data. I think we could help each other. Certainly, we could help characterize the CAC site, and I think we could potentially rule out some issues with mounts and other things. It may be that this is the best that we can do at CAC. It may be that I could do a lot better. And so I'm interested if folks have data. I'd like to talk to you about that. Okay, so I'm going to finish up real quick with going back to the field. I started as a visual observer for many, many years, and my largest eyepiece, was 1 degree. So to me, having a 1.3 degree field is awesome. All right, I have the resolution I want to chase galaxies, and I've got enough of a field to basically capture some big objects. I can't capture every big object. I can mosaic for that stuff, but I'm happy to have the resolution I want and the image quality I want to make a picture like this. So this is as big as I can go with that camera. And then the smallest I would go is an object something like this. This is 2 arc minutes on a side. And, I'm not going to go any lower than that because for me, so this is not a scope that I'm going to do a lot of work on Jupiter and Saturn with. Okay, it's not going to do planetary work, but it would get me down to a larger planetary nebula. And so with that, I think I will conclude, and I'll leave it here for a moment so that if anybody has questions or comments, maybe we can chat from here. You can see the screen, so we'll go.
Okay, that was great. I have some questions.
Okay.
Can you tell us the brand and the size of the UV IR blocking filter you're using?
Yeah, so I looked around all over the place. I needed a 72 or 77 millimeter filter. So that's a big filter. And I went to Hoya, which is Hoya is a really good camera company, Japanese company. They have a distribution center in California, Southern California. And I wound up cutting the filter out of the cell. I actually had to cut it out. I asked them if they would do it for me, and they said, "Nope, we won't do that. We're going to make you do it." so I did. I cut it out of the cell and put it in the optical window. It wasn't too hard, by the way. It sounds a lot harder than it was, but I had to use a Dremel to cut off the aluminum casing around that. So Hoya, and it's in. I left it. The name is in the briefing, so you can go back and look at the slides and find it. I actually like that Hoya filter. It's got a very sharp cut, and I like the quality of that filter. It's done well.
And the other question I had, Doug, was how often do you actually have to focus with the 11-inch RASA?
Well, I said 12 microns. That's not very big, right? So as the temperature drops, you can see, and actually, let me find that really quick, and I think I can pull that up if I can find it. I'm drawing a blank here for a moment, but at the beginning of the night, oh, here it is, sorry. Okay, at the beginning of the night, when the temperatures are falling fast, you can see that, these are 500 step increments. So, in 5 degrees, I've got 500 counts. That's enough. In the beginning of the night, I'll refocus every 40 exposures. I won't stop that until maybe halfway through the night. And then, I can slow down. And as the telescope stabilizes, I can go, 60 to 100 exposures. And at the end of the night, it doesn't matter anymore. But it's usually the beginning of the night. And if it's unstable, of course, then you might have to deal with it. But I do keep at CAC, I keep the temperature of the CAC website up on the left-hand side. And I'm monitoring that to pay attention. And so both elevation and temperature both have a pretty serious impact. I mean, you can see the elevation also. If I'm above 50 degrees, it doesn't really matter too much. But as I drop down below 50 degrees, if I'm changing from 20, if I'm chasing low targets and going from 20 to 40, I definitely have to change the focus every time I slew and go to a new target.
Is the focusing automated in Echoes, or do you have to stop the sequence and do the focus and then return?
Well, I wait, generally speaking, I won't put too many exposures in. You can automate it, so there is a delta T function that it will automatically stop, take a focus adjustment, and then go up. But I'll just put in, if I know I'm going to be focusing in 40 exposures, I won't start a sequence that's longer than 40 exposures. I'll just let the sequence conclude and then run the focus and start a new sequence. The thing about focus is that I'm actually trying to experiment with changing the eco software. I've already put some changes in for focus to log, so that's how I characterized my focuser in the first place, was from the logging that I added to the eco software. And in the end, I think the next year I'll probably put in some code changes to do focus changes between exposures. If you trust your curve and you've characterized well, you should get away with doing a delta offset. You still run your initial focus with a V curve, but you could then experiment with the idea of letting it adjust a couple, 10 counts, whatever the slope of that curve is. You could probably get away with that. And then you could run a lot fewer focus sequences. And I'm going to explore that this coming year.
And you focus on a field star, you don't have to slew over to a brighter star.
Yeah, in fact, I'm focusing on several stars in the field. So I'm just focusing on the same field. That annulus that I showed you, the target is in the middle, so that's blocked out. And it's just using several stars, whatever it can find in the annulus around there. So yeah, works out pretty well.
Hey, Doug, I have a question.
Sure.
What are you doing with the cables on the front of your scope on the RASA from the camera? Do you put them at 90 degrees, or what do you do with those cables?
You're talking about
coming out of the camera, because you've got a USB cable and a power cable.
Camera.
Yep.
Yes, exactly. And so I bundled those two cables together. It's one line that comes up and goes, it's at roughly speaking top to the center. And it's probably not precise, because if you look at my PSF and my images, you'll notice that funky PSF where I've got a little shadow coming in. It's not exactly perpendicular, but it's close. Mm-hmm. I've grown to love that PSF. I like the look of it.
And I don't know if ECOS does this, but I'm using Nina. I just started using Nina recently, and it has a really cool thing with the focus where you can set it to just run the autofocus at the HFR changes by a certain percentage between images. ECOS
has something like that as well.
So and that's kind of cool, because if it changes by 5%, by the way, it just triggers the autofocus.
Yeah, I agree with you. And I think, I failed to mention during the discussion that I looked at both SGP and Nina and really liked both of them. So I see all three of these as relatively capable, and I'm very impressed overall with all the software I've looked at. Amateur software is pretty good these days. So the only reason why I wound up going with ECOS is because of that little Raspberry Pi up on the telescope. That, I can't run Nina on the Raspberry Pi, but I can run ECOS. So they seem pretty comparable. And I think, you find good features in all of them.
Yeah, when I saw you at CAC, we were talking about balancing the scope, and you said you had spoken with Stellarium, and they talked about you wanted to be, east heavy by a few pounds.
Yeah, very surprising.
What do you do how do you do that? Just balance it and then throw it off by, that's what I do. I kind of balance it. And then if I'm photographing in the east, I just move the counterweight down a couple of inches.
Okay, so I didn't speak to that strategy, but at my house, I don't have a west view. So I'm always imaging east. And even at CAC, when I have a west view, I image east. So yeah. I balance east heavy, and I view east, and there's always enough targets coming for me to stay on that side.
At home, I'm always imaging in the east, never in the west. I have no west.
Because otherwise, yeah, you're right. You'd have to swing the counterweights, and you have to move it up the shaft. And yeah, I just want to find the balance that feels right, and then leave it there and image where I can.
Other questions?
Yeah, Doug, I have one on your camera, the ASI camera. Isn't there a UV IR cut filter in the camera already? you don't have to add one onto the scope?
I don't know if there is, that sounds a little familiar, but I don't know if it's as sharp as that Hoya filter. And it's a good question. I'll see if I can sort that out.
Okay, because I have an ASI and it's got the UVIR cut filter built in. It's an
For some
OSD.
reason, I'm not sure the 183 does. I could be
Okay.
definitely wrong here, but I think
Yeah.
I would have seen that and avoided getting the Hoya filter, but I'm happy to have the Hoya filter there.
Okay. So the other thing is, are you actually polar aligned? I didn't quite catch when you set this up on a portable basis. Are you polar aligning in any way? You're just kind of setting it up and doing plate
Yeah.
solving.
No, for sure. I do drift align. Okay, so that's my
Oh, you
polar
do?
alignment
Drift
is
align.
as a drift align. And
Okay.
I've gotten so fast and good at that I can polar align in 10 to 15 minutes, and even if I'm taking the scope down to CAC from Colorado. So that's pretty fast, but that's all I do. I just do the polar align. Once I'm satisfied with my drift align, then I don't do any N-star alignment with a hand controller. That hand controller is dead weight as far as I'm concerned. It sits up there on that deck axis and doesn't do anything all night long except that the data flow from the Raspberry Pi goes through the hand controller, and that's why I had to keep it up there on the deck axis. But otherwise, it's just dead weight.
Okay. On the RASA, you have a built-in fan and that thing. Like I think it comes with a power pack and to run the fans. Do you actually
It doesn't come with a
those?
power pack. I do use the fan. Yeah, the fan has a the fan's on the back. You just plug in a 12 volt. It's all part of your 12 volts. So I'm running what I'm running up is 12 volts. That goes to the mount itself, and it goes to the fan, and it also goes to my power box up there, the pocket box.
Does the fan run all the time, or you do how?
I generally speaking, I forget to unplug it. So yes, it runs mostly all the time. I've experimented every once in a while with unplugging it, but I haven't noticed any shaking of the OTA, if that's where you're kind of going towards. I don't think it's impacting image quality. It's not a high velocity fan.
Okay, thanks.
Mm-hmm.
Doug, I have a question.
Okay.
How long did it take you to, first of all, put all this hardware together? And second of all, how many iterations did you go through before you chose those software packages and actually got proficient with them?
Okay, so great question. Thank you for asking that, because I purchased the telescope. I considered the telescope a design project. I was interested in all aspects of it. The hardware part took me from about October, November of last year through about April of this year to put all the pieces together. Cable management was a big problem for me because cutting and splicing those cables to make them shorter, was a big effort. And then obviously changing philosophies about bundling a cable down or putting a couple cables up, all of that took time. The software was actually much easier because once I knew that I was going to put a computer up on the top, let me tell you that statement I made about simulators, and I don't know to what extent Nina and SGP have simulators, but this is the way to learn. You do not want to be learning software at night under the stars, right? I set up the simulators so that I could just run and learn everything during the day. A couple days with the simulators, about good enough for you to figure out how to use the software. And then your learning curve at night is a lot easier. So, it's been a year. Okay. I mean, so from April to now, I haven't taken an image before. So April was my first image, and here I am today. I think I've made pretty good progress, and I think it's doable. I'm retired, so it's a little unfair. If I were working, it might be a different story. It'd take me twice as long, but it's not horrible. Like everything, if you pay attention and you dig for a little while, you'll get there. It's one day at a time.
Hey, Doc, this is Kevin. I'm going to quit setting up next to you. By comparison, I've been doing this for years, and I feel like a caveman. figured out the wheel.
Well, remember, I only briefed the happy path, okay? You know, really, there's all the rest of the path is all ugly, all right?
Well, I'm happy I'm only trying to do 2 targets a night. Quick question. What's the advantage of a Raspberry Pi over these little computers?
Oh, I'm sorry, you broke up a little bit there. One more time, please.
There's these little stick computers that look like sort of a flash drive, if you will.
Okay.
And they usually have some version of an Intel processor in them. They don't have ports. I mean, basically, it's the brains of the system, which, you know, probably connect via Wi-Fi and laptop and functionally control things back there. Everybody seems to have gone to the Raspberry Pi as the onboard solution.
Well, you know, the ASI Air is a Raspberry Pi, but it's not running Ecos software, it's running their own proprietary software. But the Raspberry Pi, the other one I've heard of is a NUC. That's like a Windows component that is a little bit bigger than a Raspberry Pi. But essentially, all these single-port computers are awesome these days. They're really powerful. You can run you don't need a laptop or a desktop at home anymore. They actually have HDMI ports out of these Raspberry Pis that you can connect a monitor to and run as your at-home computer. So that's how good these Raspberry Pis are getting now.
And these things have an onboard storage to do plate solving without having to go find that off the internet?
Yeah, so I've loaded all the indices, the index files for plate solving on the Raspberry Pi. That's why I got that 120 gig drive. Maybe you only need about 2 to 4 gig. That's what I need, max, to have everything on the Raspberry Pi, so I never have to go to the internet to do plate solving. And then it's only seconds, right? We're talking 2 to 3 seconds to solve.
Cool. Okay.
So very fast.
Thanks to you, my credit card's poor because I did order an electronic focuser.
Okay, so I'm going to give up my screen now. I think, let's see if I can give it up. Here we go. Stop share. Okay, it's back to you, Greg, unless there's any more questions. I'm happy to stay as long as you want. If you guys have questions and you want to send me a note and email, we can do it.
I will post the slides that Doug presented on tomorrow, and you can wade through them at your leisure. Tom, are you ready? You need to unmute. There you go.
I'm ready, but I don't have anything as impressive as what Doug did. I've only had about a month and a half with my new mount. And so I'm just going to really kind of cover the basics, the pros and cons, and let you guys know how I feel about the new mount I bought. And I elected to go with a Skywatcher EQ6R Pro on research and recommendations. And in general, I'm very, very happy with that choice. I've had 0 issues in the month and a half that I've had the mount. And the pros on it, it's there's all kinds of things. It's got the built-in polar scope if you want to use that. I, like Doug, am using a small computer. I have the ASI Air Pro, and so I use that, and the hand controller is basically unplugged. I don't even, with the ASI Air Pro and the EQ6, I don't have to have the hand controller even connected. So that's a real benefit. You can just plug into the USB port on the side of the mount, right into the ASI Air. It recognizes the mount, and away you go. Do your polar alignment. You tell it which object you want to do. You can do sequencing right there. But I haven't gotten to the sequencing point yet. I've stuck with just single objects. It has approximately half arc second tracking when guided. I'm pretty amazed with that accuracy. It beats my AVX mount by about a factor of 4. So with the AVX, I could usually get it down to 2 arc seconds, and this thing is consistently right around a half an arc second. As we talked, it's very compatible with the ASI Air Pro. I like the fact that the mounting for the OTA is got 2 different dovetail slots. It'll take the Los Mendy and it'll take others, and easily adapts to either one. The other thing that's really nice is the counterweight shaft stores inside the mount. You don't have to haul around a counterweight shaft. It's part of the mount. The clutch releases are really positive. Right ascension and declination balance is not a guessing game with this one. It's easy to find it. It's easy to find that balance, and if you want to put a little east heavy, that's very easy to do also. Out in the tripod assembly, very stable. I mean, I've had nights where the winds are gusting to 20 miles an hour, and it hasn't seemed to affect the image quality at all. It's really stable. The other thing that I really like is the ease of access to the motors. They're all covered. It's also a belt drive. It's unbelievably quiet, even when it's slewing. And so far I've used it for my 8-inch SCT, and it handles that and the short tube 80 plus 2 cameras and LRAD, no problem. Absolutely no problem at all. So it handles that setup pretty easily. The other reason I chose the EQ6 as opposed to the Celestron CGX was it's roughly $700 cheaper. The weight difference between the two is 6 pounds. So this EQX Pro will handle 44-pound payload. The CGX would handle a 50-pound payload. Now, cons. One of the things I don't like about it, you have to adjust and lock down the set rings yourself. I haven't quite got them where I want them, but it's a real pain in the rear. It's got 2 set rings, the declination and right ascension set rings, and you can set them and adjust them, and once they're set, they'll be there forever, but it's not easy to do. It's got 2 tiny little thumb screws for the set rings, and they're hard to reach. It's heavy. Definitely probably the maximum weight that I'd ever want to try to transport. And I'm going to be getting a roll around cart where I can just set it on a 3-wheel cart with 5-inch wheels and roll it in and out of the garage rather than try to carry it. I can carry the mount and the tripod. That's approaching my max limit for hauling things around. The other thing is power draw when it's slewing, particularly at start when it starts to slew. It can be as high as 3 amps. So it can draw some pretty good amperage when it's slewing. And that's about all I have. Those are the things that I've done. Like I said, I've only had it out 3 times. The wonderful part of the thing, and Doug's really related to this, is you can put the SI Air right into the mount. You don't need anything else. It communicates directly either with my phone or my iPad. I can see the images as they come out. I can live stack if I want. It's been a pretty amazing transition from the AVX. That's all I got. Any questions?
So maybe just a question about your guiding. What do you use for a guider? Not the hardware, but the software. Using PhD or?
PhD is part of the ASI Air Pro.
Ah, okay, good. So you're using that.
Yeah, I'm using PhD.
Have you looked at the periodic air out of curiosity in that mount?
I haven't had enough time outside really do so, Doug. I need hours, and I've probably only got about 4 hours total with this mount right now. And I need to get a few more, but I've been thinking about looking at the periodic error and see what that is actually doing. It's so easy with that PhD logger, right? That log viewer is free, and if you can just go online and grab it. So I would recommend you save your logs, right? Okay. Yeah, and that way they're just there for you. Anytime you get a free moment, you can run them right into a PhD log viewer and look. It'll tell you the periodic error instantly. Yeah, I'll have to take a look at that. I haven't. I've been using about on average 2-minute subs, and I'm at the back of the scope on a C8 using a focal reducer, a 0.7 focal reducer, and I've been getting reasonable images. I really probably need to go a little longer. I do want to do what you did, and I'm going to put a LiPo filter, the L-enhanced filter in the image train, and see how that affects my images. I'm sure that's going to make it go longer. I'm going to have to get up in the 5-minute range. With guiding as tight as this is, I really don't feel that that's going to be a problem. Any other questions out there, guys? Okay, Greg, back to you.
All right,
Yeah,
any other questions for Tom or Doug?
I finally unmuted myself. It's Randy.
Okay,
I have the same mount and the EQ6R Pro, and I upgraded from an AVX like Tom did, and it's like night and day difference. Of course, it should be. It costs twice as much, but it's still less expensive than some of the others. I never would have bought it though unless I knew I was going to put it on a trolley from the get-go, because it is very heavy, and so I put it on it's been on a trolley since day one, and I keep it under the covered patio and just roll it out and set it up. But I'm very pleased with it, and I've had good results both with Hyperstar and also with the F7 reducer. And I'm able to generally shooting 3-minute subs with the reducer. I am doing off-axis guiding with the reducer, and if you can find a guide star, it works great. So anyway, for what it's worth.
all right. Well, we're just about at the end of the hour. I was going to let you know that we have some dates scheduled for the new year. The next meeting, and I guess we'll be continuing to do it via Zoom, will be January 11th and February 15th and March 15th. So those are all Mondays, and I will send out a memo to confirm all that, if you can keep it in your email someplace. And then as we get closer, we'll come up with the topics for those. Usually at this point, Tom and I ask if there are if anyone has specific topics that they would like to address or have someone address for our January meeting. Open for suggestions.
Well, how about another guinea pig for showing us, NINA or SGP or something else? Their setup.
All right.
That'd be an idea. I mean, I don't know if you guys have done this before, but at some point, maybe we should tackle some interesting post-processing topics. Yeah, I think it's too hard to do the entire post-processing thread, but maybe particular topics in post-processing might be interesting. What do you guys think?
Good idea.
We had a discussion a while ago about deconvolution and other noise reduction. I mean, it might be interesting to see how people are tackling some of those kinds of problems.
I have a spreadsheet I developed for image quality assessment and weighting. And that's early in the processing situation or in the train. So I'd be happy to demonstrate that and to talk about what variables I find useful in assessing image quality. Or these are subframes, of course, unstretched. And it's runs in conjunction with PixInsight.
Okay, I'll take that as a volunteer. Can you do that in January, Alex?
Yeah, I can do it anytime.
All
I
right.
second your motion, Greg.
And the nice thing about it is it's out there and it's free, and I'm constantly updating it. I'll find a way to make it available to people.
Awesome. Appreciate that.
Greg,
Yeah.
I might have a suggestion. I hear a lot of terminology that I don't really understand real well. Things like convolution, or you had modeling issues that you were talking about. I mean, the terminology words that I've heard are, well, I probably could make a list of 30, 40 of them. A lot of them I don't quite understand. Some of them I've figured out, but it might be helpful for those who are newer to this game or trying to understand it better to maybe have someone explain with examples of what this is. Something like dithering. An example of what dithering does and how it improves the image. Just to throw a possibility out there.
Okay, that's a good suggestion. Did you get the email that I sent out earlier today with the PDF from NASA? Smartphone photography?
I did get it. I haven't had a chance to look at that link, but I
You
saw
really
it.
need to have a look at it, because it's really an imaging textbook that they don't really talk about the smartphones until like chapter 8 or something. And there's a lot of good information in there on just about everything from, calibrating images, why you calibrate, how to focus. So the guy who wrote it, I guess, had the idea that people wanted to use smartphones to do astrophotography, but he covered about everything else in addition to, actually using a smartphone. So I was kind of amazed when I started looking through it. I kept wondering, when is he going to get to the bit about the smartphones? And eventually they do, but a lot of good information in there. And he does go into just discussing a lot of the terminology that we've been throwing around, like dithering and, pixel resolution calculations, that sort of thing. So
You know,
if you have a
if
chance to
anybody
take a
out
look
there-
at it. It's
if anybody out
190
there-
some pages.
If anybody out there has one of the Google Pixel phones, it uses artificial intelligence to do its low light photography. If you set it on a tripod and push the button, it'll take 5 subs and stack them and use AI to correct for the dim light that you have. I'd really love to see one working, but I don't really want to buy a new phone yet. I still have a pretty good one. But if anybody has one, I'd love to see what it can do.
That's great too. Anybody have a Galaxy phone that they want to do that for us? No takers. All right. Well, I think we'll call it an evening, and it's clear out if that's of any interest to you.
Can I just ask Wendy? Wendy,
Sure.
are you new to the club?
No, I'm not. How long have I been coming around now, Greg? I think for almost a
For
year.
a year.
Yeah.
All right. Well, I hope to see you at the women's. Do you go to the women's?
I do not. I'm usually working.
Oh,
I'm multitasking as it is right now.
uh-huh. All right. Well, nice meeting you.
Same here.
Mhm.
And thanks, Wendy, for setting up the Zoom meetings. We really appreciate that.
Oh, it's my pleasure.
All right. So,
Hey, Greg,
yeah.
I think we can answer that earlier question, by the way. It looks like, as best I can tell, the 183 does not have a UVIR cut filter built in. It's got an AR window. So it's anti-reflection, but it's not UVIR.
Yeah, and
So,
sometimes the anti-reflection's not that great either.
yeah, so I think, I hope I would have discovered that earlier, but I could still be wrong. So
All right.
just FYI.
All right. And that was a 72 millimeter filter?
I will send you that message separately. It's either 72 or 77, and I screwed it up so many times that I better go check it before I commit to one or the other. 72 or 77.
All right. Well, thank you, everyone. And thanks, Wendy, for recording this. I'll wait to get the recording from you.
No problem. Thank you.
Okay.
Everybody.